Hello, ladies and gentlemen. Today we are going to take a look at other types of proofs that you can have involving congruent triangles. So basically, we're going to be proving other things besides just the fact that the triangles are congruent, but we're going to use our congruent triangles to help us do that. So we're going to be proving other things today. This is otherwise known as the special thing called CPCTC. You'll find out in a minute, okay? For this, you need your notes as well as something to write with. So proofs we have already done. You guys, we've done a lot of proofs like this where we were given that certain segments are congruent to other segments, and our goal is to prove the triangles are congruent. And you can see that right here. My goal was to prove the triangles congruent, and the proof shows that the triangles are congruent by side angle side. But what happens when our proof doesn't get to stop right there? That we weren't trying to prove triangles were congruent. In fact, we were trying to prove something else, like the fact that angle A is congruent to angle D. That doesn't mean we can't use what we already know about congruent triangles, because we can, but we're going to add a little extra step there after the triangles are congruent, because if these two triangles are the same, ladies and gentlemen, that is, if AB is congruent to BD and BC is congruent to BE, and we had vertical angles in here, that's what the proof says, and we see the triangles are in fact congruent, then wouldn't it make sense that angle A would have to be congruent to angle D? That this angle up here would be congruent to this angle down here. Wouldn't that make sense? Well, yeah, it makes sense if the triangles are already congruent, that all their corresponding parts would match up as well. So instead of stopping our proof at side angle side, we would add on that angle A is congruent to angle D because of what? What would we write right here? And that's where we look at what we're about to do today. So if the triangles are congruent, ladies and gentlemen, get this part into your notes. If the triangles are congruent, then we know corresponding parts of congruent triangles are also congruent. So that means if we have congruent triangles already, then their corresponding parts, that is all the pieces that make up each triangle, will be congruent as well. So once we know triangles are congruent to each other, we can then say, yep, these triangles are the same. That means that angle B has to be congruent to angle D because their corresponding parts of congruent triangles are congruent. So that's our last step that we're going to be adding on many times today. Not always the last step, but almost. And we're going to write some proofs using that information. So here are some proofs we need to get into our notes. We are going to prove the following statement. We're given that segment AB is congruent to segment CD, and that angle BAC is congruent to angle DAC, and we need to prove this, that BC is congruent to AD. Now, we can't just say that they're congruent because they look like it. We have to write a formal proof with explanation as to why they're congruent. So the fact that BC and AD are both pieces of triangles here, they would be corresponding parts of the two triangles. If we could get the triangles to be congruent to each other, then we would know that we would have corresponding parts. So let's first write the proof like we normally would do to get the triangles congruent to each other. So notice I've already had the given written in there. What would step 3 be right here? Well, step 3 might be that they share this side right here. So we'd say AC, segment AC is congruent to segment AC by the reflexive property. And then we would then say, you know what? Now I have triangles that are congruent. So step 4 is saying that I would have triangle ABC congruent to triangle, then I'd start the next one at CDA, and we would say that's because I see side angle side. But that wasn't our end goal, wasn't just to get the triangles congruent, it was to get these two parts of those triangles congruent. So now because we have congruent triangles, I know any piece up here has a corresponding piece in the other triangle. So I would say then that yes, I will now know that BC is in fact going to be congruent to AD because corresponding parts of congruent triangles are congruent. Rather than writing that phrase out every single time, this little symbolic notation or abbreviation stands for that phrase. All right, let's look at another proof. Number 2, we are given the fact that AB is congruent to DC, given. And we are also given the fact that AD is congruent to BC, given. And we need to prove that angle A is congruent to angle C. Well, we can't just say that they are because they look like it again. Let's get those triangles congruent to each other, and then we'll be able to know that for sure. So again, they're sharing this side right here, so we'll say DB or BD, either way, is congruent to itself because we see the reflexive property happening there. And then we would now have the two triangles congruent to each other by side, side, side. So I would say triangle ABD is congruent to triangle, let's go CDB, by side, side, side. Now that we have the triangles congruent, now we can match up any corresponding parts that we would like. And we wanted these two angles congruent to each other. So now we can say angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. Or CPCTC. Third one, let's do one more proof in here. So we're given that KM is perpendicular to JL. You can see this proof is going to be a little bit longer. This is given as well as JK being congruent to KL, and that is given. All right. So how would we go about writing that? Well, we know with the idea of perpendicular, and in fact, it even has the 90 degrees shown right here, and we already have the fact that we have those two little congruent marks. So what we could say then in step 3 is that we notice the shared side would be good. We could also need to point out, let's point out here that we have another right angle over here. Okay, let's do that. But let's also say this was talking about perpendicular, so let's maybe make a note in our proof that this angle and this angle both are 90 degrees. So we could number them if we want to. We talked about that, angle 1 and angle 2. So we could say angle 1 and angle 2 are right angles. And how did we know that other than the fact that it was written in the diagram there? Well, we saw the perpendicular. So we saw that there was a definition of perpendicular that we saw in the given information. We could say definition of perpendicular. Now let's talk about the shared side right here. So we could say that KM is congruent to KM because it's reflexive property. It's a shared side. Now, looking at those two triangles and what they have marked, we see hypotenuse leg, you guys. That's what we see. So I already know the triangles are congruent by JKM is congruent to triangle LKM because I see hypotenuse leg. Well, what else would we need? Well, notice what I'm trying to prove is that M is the midpoint of JL. But I don't even have equal segments over here yet on either side of M. So that would be my next step. I would say JM has to be congruent to ML. And why would that be? Why would those two segments have to be congruent? Don't use midpoint because midpoint's what we're trying to prove, not something that was given in the given information. But those two things would be corresponding parts of congruent triangles are congruent, okay? Because those two little segments there represent corresponding parts of two triangles that happen to be congruent, we know that those two pieces will match up or be congruent themselves. Now that I know those two pieces on either side of M, here and here, are congruent, I now know that we've shown M is for sure the midpoint of JL. And how do we know? Because I've just shown that the segments on either side are congruent, and that would be the definition of a midpoint. So this is an example of one where we didn't end with CPCTC. We continued one step further to prove that something was a midpoint or something was a bisector, that sort of thing. But our new step that we're introducing in our proofs in days to come will be CPCTC, the fact that we can prove other things once we have the triangles congruent. Okay? So I want to thank you for taking good notes today on your 3 proofs, and I will see you later.